All right, so CES 2026 is officially behind us. The convention center is quiet.
And our job begins.
Exactly. Our mission now is to, cut through all the noise, skip the simple hardware stuff, and really get to the big strategic shifts we saw this year.
And for the third year in a row, the big headliner was AI. No surprise there.
None at all.
But the flavor of AI was totally different. Last year, it was all about agentic AI, these software agents.
Right.
This year, the buzz was all physical AI. I mean, robotics were absolutely everywhere. It's a huge move from the cloud into the real world.
And to power that physical world,
Yeah.
you need some serious, serious infrastructure. Which brings us to NVIDIA.
Of course.
They had their big architectural reveal, the Rubin computing architecture.
Yeah.
And they're saying this will start replacing Blackwell in the second half of 2026.
That timeline just feels frantic.
It is frantic. I mean, it begs the question, right? Is that speed a sign of pure dominance, or are they scrambling to keep up with the demand?
That's a good point. But what's really fascinating is how it connects directly to that physical focus. They also introduced Alpamayo, which is a whole family of open source AI models for autonomous vehicles.
So they're building the brain and the nervous system.
Exactly. Their whole goal is to make their infrastructure the, quote, Android for generalist robots. They want to be the OS for everything that moves.
Which sets up a perfect contrast with AMD's approach.
A completely different angle.
Yeah, AMD's strategy felt much more grassroots. They were focused on expanding AI for everyday people, through personal computers, with their new Ryzen AI 400 series processors.
It's the battle for the desktop, for the home user.
Totally. And if you connect that infrastructure back to actual applications, you can really see it taking hold in these complex industrial settings.
Oh, absolutely.
The partnership between Caterpillar and NVIDIA was a standout. They showed off their Cat AI assistant on an actual excavator. It wasn't just a simulation.
And that's a high-stakes environment. It has to work.
But when you shift from that industrial success to the consumer side, well, that's where you get the reality check.
A big reality check. LG's home robot, COLOID, was a great example. It was sort of their figurehead for the show.
And the demo was, let's say, laborious.
Laborious is putting it mildly. The fact that reporters used the word gingerly to describe it placing a shirt into a dryer says it all.
The image of it gingerly putting a croissant in an oven is just perfect.
Yeah.
It shows the massive gap between the ambition and the messy reality of a home.
It really does, because handling a soft t-shirt is an incredibly hard problem for AI dexterity. It's why you see these big research partnerships like Boston Dynamics teaming up with Google's AI lab to train the Atlas robots. They're tackling the really hard problems.
Meanwhile, on the software side, things are getting very strategic. Look at Ford.
Right, in the app first.
In the app first, with a 2027 target for in-vehicle.
And the key detail there, I think, is that they're building it with off-the-shelf LLMs.
Hosted on Google Cloud.
Yes, that's a huge tell. It means AI is becoming a component you buy, not something you build from scratch. The competition is shifting.
Which ramps up the pressure on the interface owners. It's why Amazon was there in such a big way, launching the Alexa Plus chatbot on a new Alexa.com. They're fighting to own that assistant space.
But look, CES wouldn't be CES without the wonderful oddities, right? The stuff on the fringes.
Oh, for sure. The phone from Clicks Technology, the communicator.
With the physical keyboard.
Total BlackBerry vibes for $499. It feels like a genuine test to see if nostalgia sells.
Then you had Razer with its concepts, Project AVA, an AI avatar for your desk, and Project Motoko, which is trying to give you smart glasses features, but without the glasses.
And we can't forget Lego, their first ever appearance at CES.
Which is wild to think about.
They showed off their Smart Play system, where the bricks and the minifigures actually interact and make sounds. Physical AI, starting with kids' toys.
So putting this all together, what's the big takeaway here for you?
I think it's that AI is no longer just some theoretical code living in a data center.
It's being engineered directly into physical hardware, from the most complex architecture like Rubin all the way down to a Lego brick. The theory is now tangible.
And that leads to the final provocative thought for everyone listening. We heard this idea in one of the sessions that the learn once, work forever era is completely over.
It feels that way.
So given the aggressive case we're seeing, with NVIDIA replacing architectures this quickly and this universal push into physical AI tools, the real question is, if our tools are iterating this fast, how quickly do we all need to adapt our own skills just to keep up?